Okay, so we don't know the first term. So in order to write the rule, a general rule, you need to know the first term in the common ratio. So let me just rewrite the formula. T sub n equals T sub 1. This is the format for a geometric general rule. So in this example, T sub n is negative 243. N is 6 because that's the sixth term. R is negative 3. So we're substituting these three pieces of information into our formula. So negative 243 equals T sub 1 times negative 3 to the power of 6 minus 1. So negative 243 equals the first term times negative 3 to the power of 5. This is an actual number, so I'm going to divide both sides by negative 3 to the power of 5. So in your calculator, you need to type in negative 243 divided by negative 3 to the power of 5, and that will be your T1. So go ahead, take a minute and figure out what that T1 would be. So you should get T1 is 1. Who got that? Positive 1. So now you're ready to write your rule. So your rule, I'm going to write it over here, would be T sub n equals 1 times your common ratio. You don't have to put that 1 in parentheses. Let me take that off. 1 times your common ratio to the power of n minus 1. Common ratio is negative 3 to the power of n minus 1. So that would be your rule. Go ahead and use that rule to find T9. That's what it told us to do in our direction. So T sub 9 would be 1 times negative 3 to the power of 9 minus 1. Type that in your calculators. And what did you all get? 4? I don't think it's a big number. Oh, okay. You have to put the negative. So what did you all get? Positive or negative? Yeah, it should be positive because you're taking negative 3 to the power of 8. And the negative to an even power is positive. All right, so I know I kind of wrote all over the screen. I'm going to leave that there for a second before I erase it all to do part B. But I want you all to try to do part B on your own. I'm going to give you a couple seconds. You know T5 is negative 64 and R is 2. Find the first term and the ninth term. Okay, so I got -4 for T1. Anyone else get -4 for T1? And then I wrote my rule, and that's my rule. Because you're taking -64, dividing that by 2 to the 4th. 2 to the power of 5 minus 1 is 2 to the 4th. So I just put it in as 2 to the 4th. So -64 divided by 2 to the power of 4 is T1. So T1 is -4. So you wrote your rule. Now use that rule to find the 9th term. So T9 would equal -4 times 2 to the power of 9 minus 1, which is -1024. And that's what I got for my T9. All right, anyone else have that? Okay, we got a couple of word problems. I am skipping around a little bit. Some of the questions are repetitive, and if I feel like we've covered it, I'm not going to cover it again. So we're actually going to our word problem featuring Kimmy, which has a typo in it, and I feel so bad. But okay, so it says Kimmy was playing tennis. After one hit, the tennis ball continued to bounce until it eventually stopped. The highest point of the ball was 6 feet. So now the tennis ball accidentally changed to a basketball, but that's okay because it's magic. Magic happens. So each time the ball bounced, it rebounded 2/3 of its previous height. So why is this geometric? It's geometric because we're multiplying. Yeah, we're on number 8. Sorry, multiplying by 2/3. That's why this is geometric. So when we write a rule, T1 is the height that we started off with, which is 6. And my common ratio is 2/3. So my rule would be T sub n equals 6 times 2/3 to the power of n minus 1. So for part C, this is like a little tricky because you may think that you're substituting in a 5 for n, but you're not. So I'm going to try to draw this diagram the very best I can. I'm getting better at drawing this diagram. Okay, so this height, every time the ball bounces, and please don't make fun of my drawing. It's not the greatest, but, you know, it works. So this is the ball. Every time it hits the ground. Oh, I need another bounce. Hold on, let me add another bounce. Okay. So this initial height, 6 feet, that's my T1. So after it hits the ground the first time, the next height is T2. After it hits the ground the second time, is T3. So after it hits the ball, after the ball hits the ground, the 5th time, we're really looking for T6. Okay, so you're substituting in a 6, not a 5. Okay, because we started off, this initial height is T1. So the ball hits the ground after the first bounce, it rebounds back up, that's T2. After the second bounce, it rebounds, that's T3. After the third bounce, it rebounds, that's T4. After the fourth bounce, it rebounds, that's T5. After the 5th bounce, because it says after the 5th bounce, we're looking for T6. So put a 6 in your general rule formula. So we have 6 times 2/3 to the power of 6 minus 1, which is 5. And most calculators give you a fraction, which is fine. You could say 64 over 81. You could also write that as a decimal, which would be approximately 0.79 feet. All right, I want you to look at the next question, see if you can set it up. It's very similar. So you have a question like this in the homework where it's a ball rebounding. So you're adding 1. If it says after, you need to add 1. It's kind of a tricky question. Hopefully my little diagram was a little better. Okay, so going to number 9, we have another ball. It's dropped from a height of 30 feet. It continues to bounce until it finally stops on the ground. If the ball rebounds to 3/4 of the height, then answer the following question. What type of sequence is this and why? Write a rule. And then what is the ball's rebound height after the 4th bounce? So I'll give you a few minutes. Okay, so I'll give you a chance to compare your answers. So you're multiplying by 3/4. That's why it's geometric. The rule would be Tn equals the first term times the height to the power of n minus 1. Hopefully the diagram helps you understand why you're looking for T5 and not T4. And I would take that answer as a fraction or a decimal. I think the yellow calculators give you a fraction. You can also write that as a decimal. All right, what did we miss? What are you all thinking? Yes. You put the 5 instead of the 30? Oh, okay. So you got the formula confused. Yeah, so it's always the initial height, T1, times the common ratio. So there's 5 formulas, and I'll talk to the other teachers to verify, but in the past we did not give formulas, but I'll verify. There's 5 formulas that you need to know, though, for the quiz. So now we're going to introduce the 4th formula. which is a geometric sum. We talked about arithmetic sum. Now we're going to talk about geometric sums. But before we get there, because we're almost finished, does anyone have any questions about number 9? All right. Oh, no, go ahead.
All right. When we see the word rebounds, we should know that it's automatically geometric.
Yeah, because it says, actually the word in here that tells you multiplication is of. If you take 3/4 of something, 3/4 of anything is multiplication. So if I say I need 3/4 of, I don't know, my students to get an A, that means I need to multiply how many students I have by 3/4. So the word of implies multiplication. So that's a good question.
See, I can ask a good question.
That was good. Yeah, that was a good one. Any other good questions? Or not so good questions? You're free here, free to be you. Okay. Oh, I lied to you. You got one more question. Then we do to geometric sums. All right, let's look at question 11. I know I'm skipping around a lot. Just skip over them. We might come back to them. We might not. I don't know. Find question 11 in your note packet. Now, this is similar to the question we started off with, where I told you the 11th term. I told you it's geometric. I want you to find the first term, and then I want you to write a rule, and then find the 15th term. So we might go back to cover 9 and 10. I don't know, but I felt like they were repetitive, and I wanted to get to some new material. So take a minute, see if you can find this one on your own. No, you get a fraction, and I really want you, thank you for reminding me, do not convert it to a decimal. It's easier to keep it a fraction only because this particular fraction is a non-repeat, is a repeating fraction. So if you change it to a decimal, you're gonna change the accuracy of the rule. So for this example, I just really want you to keep your answer as a fraction. Do not change it to a decimal. So if you got 1.3, whose calculator gave them a decimal? Do you know how to change yours to a fraction in your calculator? Yeah, change it to a fraction. Because if you use 1.33333333, your answer for the second part is going to be wrong. Yes. You could, however, when you do, like if that was your rule, I would accept it, but your answer for part B is not going to be right unless you use a fraction. Okay? So for the second part, in order to get the right answer, because if you were to type it in, if you type in your calculator to find T sub 11, if you type in 4/3 to the power of 3 to the power of 11 minus 1, you get a different answer if you use 1.3. And it doesn't matter how many 3s you put in there, it's still not going to be accurate. So the answer that you get for these two
Is it
are
11 or
different.
15?
I'm sorry?
Is it 11 or 15?
It's 15. Thank you. The answer that you get is different. So that's why I would just prefer that you just use the fraction. Because again, if you type it in this way, you actually get an answer that is pretty far off. Like they're not even that close. So this is the best answer. So to avoid inaccuracy, let's just use the fraction. So when you type it in your calculator, you have 4/3 multiplied by 3 to the power of 14, and you get 6377292. That's what you get. But if you use the other formula with the decimal, 1.33 times 3 to the power of 14, you get 6361348.77, which is wrong. So let's just avoid that inaccuracy and stick with the fraction. All right, any questions about number 11? I doubt it. I ain't thought about it yet. Because the quiz isn't until like the 13th.
For this? Oh, really?
Yeah.
How many things are we learning?
No, it's not next week.
Good.
It's like a week and a half away. I don't even know if a review exists. All right. I don't know. I have to look. I don't know. All right. So let's look at this next formula, our fourth formula. Now, in your notes, there is a K in the box. Go ahead and cross that out. We don't need K. We need 3 things for a geometric sum. The 3 things you need to know are your common ratio, how many terms, and the first term. So the fourth formula says to find the geometrics for a geometric sum is T sub 1 multiplied by, you have a fraction, 1 minus r to the power of n divided by 1 minus r. All right, so we only have 2 more questions and then we'll be finished for today. So looking at these 2 questions, because we've talked about the sigma before. On the test, it's going to have a sigma, which means that it's either arithmetic or geometric. You have to know the difference from looking at the rule. This rule tells me that it's geometric. What in this rule tells me it's geometric? Not the n minus 1. I think I heard somebody say it. Exponent. So let's write that. If there is an exponent in the rule, exponent in rule is a geometric series. Because on the quiz, it doesn't tell you that. So the mere fact that I have this exponent, I know this is geometric. So remember, there's only 3 things that we need to know. We need to know T1, we need to know R, and we need to know n. T1 is the number in front of the base. So my first term in this example would be 5, because this is a geometric general rule. So 5 is my T1. What is the common ratio? 3. And what's the number on top of the sigma? 5. So in your calculator, the sum, you have T1 multiplied by 1 minus r to the power of n divided by 1 minus r. So it's kind of an ugly formula. Go ahead and type that in exactly like that.
So we're not doing that thing where it's like T of 5.
Or you have to find the last number.
Yeah.
Nope, you don't need to find the last number for a geometric. For a geometric sum, you just need to know 3 things. The first number, how many terms, and the common ratio. So I got that my geometric sum is 605.
That exponent of 5 isn't outside of the parentheses.
No, so let's go back. Let's look at this formula. So make sure you write it, copy it down exactly the way I have it written there. Now for question 2, and we'll end after question 2. We have our first term is what? What is our first term? 2. Good. What's our common ratio? Negative 1.5. And how many terms? Is that, what's the number at the top of the sigma? 8. Now when you have a common ratio that's negative, you should put this in parentheses in your formula to get the correct answer. So when you type it in your formula, the sum is going to be T1 multiplied by 1 minus, now I'm going to introduce a parentheses and put that negative inside of the parentheses, over 1 minus negative 1.5. And all of this is in parentheses. So that's how you want to type that in your calculator. So someone, and I don't know if someone's going to ask this question, but I'm just going to answer it anyway. Someone asked me, why can't I just make this a plus? Does anyone know why you cannot do that?
It's been multiplied by 0.
Because of the exponent, yes. So, because if you were to change this to addition, then you're going out of order. Remember, there's an order of operations. Exponents come before you multiply. So you cannot, even though the denominator would change to a plus, the numerator would not. So I don't want you all to get confused. That's why I would just put my negative common ratio in parentheses and type it in just like that. That way you can't miss. Can't miss. So let's set ourselves up for success. Just type it in our calculator the good old way. I think I already typed this in, but maybe I didn't. Oh, there it is. Okay, and you do get a decimal because we have a common ratio that has that's a decimal, so that makes sense. So negative 17 point. I'm just gonna go out to the thousands place. As always, unless the directions specifically state where to round, I don't really have a preference. I would not mark off for that. And that would be my sum. Homework 25 is due today. We're almost finished working through the questions in homework 26. And then we'll end there. If you need help typing this in your calculator, did anyone not get that answer?
I did not get it.
You did not? What did you get?
Like negative 78.85.
Did anyone get this answer? Let me make sure I typed it in right, too.
I had it typed in.
Negative 1.5 separate. No, that's what I got. I'm confident. Let me see yours. Let me see how you typed it in.
I think.
Oh, you know, you didn't type it in right. Because you didn't put 1.5, you put 0.5.
Oh, wait, no, that's for the other one. This is.
Oh, okay, this is this one?
Okay.
T1 is 2. You put that T1 is 8. So that's why.
I did the parentheses right. I was just.
What time did you go to bed?
Okay.
What time did you go to bed last night?